Hello everyone, my name is Jeff, and today I saw this comment on one of Jonathan Blow's videos regarding Jonathan Blow on simplicity, whatever. Anyways, I saw this comment. It was like Casey, spaghetti code Casey. Kind of like I guess you could say trying to like kind of belittle Casey, like oh, because he writes spaghetti code. Okay, and then like I thought about it, I was like, well, I keep hearing the word spaghetti code come up, and it's like, is spaghetti code bad? Okay, well, it really depends, but yeah, sure, spaghetti code, it can be bad, it can, but I think generally, the if you had a vision for the optimal kind of program, that it was not monolithic. This program had it was in all different files and stuff, and because we use files as like a way of organizing. It's all in different files, and if you had the optimal like code, I guess you could say, for the prettiest code, the most cohesive code, and I think it would be spaghetti code. That's me envisioning the optimal route. Assuming that you're splitting it, assuming it's not monolithic, you're splitting things into different files. I think it would be spaghetti code. So I don't think definitively you could say that because it's spaghetti code, it's bad. I sure think there is a lot of bad spaghetti code, but I think the optimal result of a program in that software that's the architecture is in different files, I think the optimal result would be spaghetti code. And here's like why I think. So imagine you have like a game, okay? There's a bullet, I guess you could say module, let's call them modules, okay? There's going to be character, there's going to be air, entity, tree. It doesn't really matter. Okay, well, air is like the sky. Let's say that, the bullets fly through the air. So kind of like, I mean, you could kind of think about it like, air and bullet kind of have to know about each other, right? Because if they don't know about each other, then air can't have any effect on bullet as much as bullet cannot have any effect on air. Same thing with tree and air. Like imagine, for example, you shoot a bullet, and the air just like kind of, vortexes or whatever you call it, and there's a tree next to it. Sorry, my horrible fucking illustrations. You have a tree. You would expect the leaves to like blow off into the wind or something. Who knows? You would expect some kind of reaction to happen. Well, nothing's going to happen if you just don't connect these kind of things to each other. Tree, has to pull in information from air. Of course, you could say that. Of course, you could make the argument. Okay, well, maybe these are all. These are really the same thing. You could say, okay, these are all in the same file, maybe. Sure, yeah, I mean, they could be in the same file. Air and tree as a single file. But even in that case, them being in the same file means that they have access to each other. They're in the same scope. We're not putting arbitrary constraints on the scope of the program that could perhaps change the direction unintentionally. Just because these things are separated, in our minds we're kind of creating if you think about it, we're creating direction for our program to be in. Oh, these things are not in the same area, they're not in the same files, so we're just going to kind of like pretend like they're unrelated then. Or not even pretend, it's like you just inherently put that in your mind because they're in different files. So it's like, okay, that's fine. So anyways, that was kind of a little tangent, but so, okay, air and tree have to be sharing context with each other. Air has to be aware of tree has to be aware. Okay, well, bullet also has to bullet and air have to kind of work together in order for the bullets to have effects on air. And okay, so like this is the idea for an optimally cohesive piece of software, as in a change in a seemingly completely unrelated part of the program perhaps could, if it wanted to, it should, if it wants to, it should be able to do whatever it wants to any other part of the program. because just because these things are in a different file should not mean that it can't interact with that part of the program. If we have a character, and I don't know if I should have called this entity and character. It doesn't matter. The names don't matter. But in the case of bullet, air, tree, okay, well, bullets should be able to kill the character. They have to know about each other. The character can interact with the air just walking, moving air around it because it's walking. The character falls. Maybe there are aerodynamics. The character has a terminal velocity because of the air resistance. The character could bump into a tree, perhaps. Maybe these things could be abstracted into a single thing like called environment or something. Who knows? But regardless, if we are even putting them, if we are putting saying, okay, this is environment, in the end, we're still just saying that it's environment is to make these things aware of each other and just call it another thing. We're just labeling things, right? So it shouldn't be the case that just labeling things creates a constraint on our program. It should work. These are just as much as if we were to have our program as a single monolithic kind of thing. Let's say that, let's call this, okay, so let's say that this is called game. So here's our game, right? This is game. Game is this idea of this entire kind of system that is completely, game is a game. That's it. Game is a game, okay? And in game, everything is aware of everything, right? Now, game could be, if you think about it like this, okay, game could be represented by all of these different files kind of coming into one single an ecosystem of files. This is our file structure. This is our software architecture. This is our hierarchy of information. Okay, we could represent a game like this. We could also represent game as just a single monolithic file. Okay, right? So in the end, okay, and here's where the argument comes. It's like, do you want your game as a single monolithic piece of code where you're probably going to have a million lines of code? Well, no, you probably don't. I mean, it depends on what you care about. If you want organization, I don't think you would want to. So yeah, but you surely would want to have your things in multiple files. That way you could, maybe have all these different files. You know exactly what each file contains. Well, entity has things related to entity, tree has things related to tree. That's just, it's more appealing. It's more appealing to us humans. So that's the kind of thing. So this is why I believe that no, spaghetti code is not always bad code. But then, yeah, sure, you search online. Okay, what is spaghetti code and why is it bad? And okay, here, code over time becomes increasingly complex as more and more developers work on the same product. Okay, so maybe it's a problem instead that actually we're having more and more developers work on a product. Because that, understandably, yes, if you're having multiple people work on a project, well, they're not even all in the same mindset, so how could they even make meaningful judgments on the program? How could they make meaningful judgments on where the program is supposed to be going? If everyone's, it's like, okay, so I don't know, I like to make this kind of comparison, but if you're on a golf course, and let's say you want to know where the goal is, and let's say you know the goal is below, you know that the goal is below you. So, but you can only see, so there's fog. It's really foggy. You're standing right here. Okay, and you know the goal is below you, so okay, you're going to assume, well, I can't see past here. What's the best decision for me to make? Okay, well, there's a slope down here. I'm going to go this direction. Okay, well, it was a good effort, but it's not right. This is not actually where the goal is, but you tried. You can't. This is another tangent, by the way. I'm sorry. Okay, So you're not in the right place. But in terms of your own scope of the problem, in terms of your own your scope, this was the correct solution. But you can't really know what the solution is until you know everything. And you can't really, because so until you know everything at once is when you know the problem. Right? So you can't just know little parts of the problem. And you really can't really make meaningful contributions if you're only working on little parts of a problem. Like everyone is working on a little part of a problem that's kind of going in different directions. So we have maybe people here, we have people here, we have people here. So do these people's work really actually mean anything? I mean, sure, this guy would be lucky right over here. He would go in the right direction. This guy would also go in the right direction. But would it be more productive to have a lot of people working on this problem in different parts of a problem? Would it be more, well, obviously it would be more productive to have someone that just knew the vision, that had the vision for the entire kind of problem. And regardless of where this person is, they know which direction to go. And, even if there are two people working on this, if they're both in the same scope, if they're both in the same mindset, then sure, maybe they could get to the problem faster. Thanks to this guy, they got there faster, I guess. I don't know. That's probably not really a good comparison, or a good analogy. But, I think there was another thing I wrote down. I was writing some notes, so I don't actually think monolithic code is good, to be honest. But in terms of getting things to, in terms of the least constraining system, and if you have an idea and you just want to throw it out and you just want to get things on paper, it's like the best way to draft, I think, is probably writing just like a monolithic program. You have just have a single fucking file, write all of your code in it, and then I don't know. From then, if you wanted to, you could separate it into files if you wanted to. It sounds kind of unrealistic, and it actually probably is unrealistic. Maybe. Okay, and then another thing is like there is a difference between, I think, having spaghetti code and just having like piece of shit code that doesn't really make sense, convoluted shit that is just like, okay, I don't really get what's going on. Sure, that is absolutely a bad thing. That's bad practice. But I think if you're taking if you're looking at the optimal spaghetti code, you could have beautiful code. If you're looking at shitty spaghetti code, of course it's shit. But if you look at objectively, what is the most beautiful program or software design, architecture design that consists of multiple files and separating your things into files, the outcome would be spaghetti code, I believe, because it's the same as a monolithic program and just separating it into files. And a monolithic program is the most cohesive program you could have, I believe. So, I don't know, that's... Actually, I made a mistake. Monolithic is not the most cohesive program. It is easy to make cohesive programs in a monolithic design. That's what I was trying to say. I think that pretty much covers what I wanted to say. Yeah, I think that's it. But anyways, thanks for listening.